Solve 3x minus 2 to the 1/2 power minus x equals 0. Again, I'm going to rewrite this. However, I want to point out that when we raise something to the 1/2 power, that just means that we're taking the square root of it. So this is really equivalent to the square root of 3x minus 2 minus x equals 0. So don't get nervous if you see an equation that has a fractional exponent in it. A fractional exponent just corresponds to a radical. So now that we have this written in radical form, we know that we're eventually going to need to square both sides to get rid of the square root. But remember, before we do that, we have to isolate the radical. So we need to get rid of that x on the left-hand side, and we can do that by adding x to both sides. This gives us the square root of 3x minus 2 on the left and x on the right. And now that we've isolated that radical, we can square both sides. When we do that on the left, we're just left with 3x minus 2. And on the right, this x squared becomes x squared. Again, we're in a situation where we have a polynomial equation because we've got an x squared. It's actually a quadratic equation. And to solve these, we need to get all of the terms on the same side so that the other side is equal to 0. We could subtract x squared from both sides to effectively move this x squared to the left, but I want to keep the x squared on the right-hand side so that it is a positive x squared instead of a negative x squared. So I'm going to move all the terms from the left to the right-hand side. I'm going to do that by subtracting 3x from both sides and adding 2 to both sides. This leaves us with 0 on the left, and on the right we have x squared minus 3x plus 2. Now that we've got all of the terms on the same side with the other side equal to 0, we can factor this trinomial and use the zero factor property to finish solving. On the right-hand side, we can unfoil this. We need two numbers that have a product of 2 and a sum of negative 3. Those numbers are negative 2 and negative 1. And now we can set each of those factors equal to 0. X minus 2 equals 0, or x minus 1 equals 0. And solving these gives us x equals 2, or x equals 1. So we have two potential solutions, and we do need to check both of these because we squared both sides of the equation at one point. So let's start by checking x equals 2. If we plug that into the original equation, and I'm going to use this for the original one, writing this as a square root instead of a 1/2 power is effectively the same. So we're going to plug in x equals 2. So when we do that, we have the square root of 3 times 2 minus 2 minus 2, and we want that to be 0. Let's evaluate the radicand. 3 times 2 is 6, and 6 minus 2 is 4. So we end up with the square root of 4 minus 2 equals 0. The square root of 4 is just 2, so this gives us 2 minus 2 equals 0. And we know that's true, so x equals 2 is an actual solution. Now let's check x equals 1. If we substitute x equals 1 into the equation, we have the square root of 3 times 1 minus 2. Minus 1 equals 0. If we evaluate that radicand, 3 times 1 is 3, and then 3 minus 2 is 1. So we have the square root of 1 minus 1 equals 0. The square root of 1 is indeed 1, and 1 minus 1 is indeed 0. So this also checks. And so in this equation, we actually have two solutions. And so our final answer is x equals 2, or x equals negative 1.